Warm welcome and very good morning, dear students and friends. Today I am going to take a video lecture on simply supported beam carrying a UDL of 10 kilonewton per meter and for a span of 4 meter. The total span of the beam is 4 meter. So here our aim is to find the maximum bending stress and the shear stress at mid span of the given section. Here the beam section is of a circular one which is of 300 mm diameter. So that is 150 mm radius. So due to a solid circular beam, what about the reaction at the support end? The reaction at the support end will be of VA and VB, which is equal to UDL is 10 into 4, so totally 40 kilonewton. So because of symmetrical loading on the beam, the reaction will be the same at support A and B. So that is equal to 40 by 2, that is 20 kilonewton. So here our aim is to find the maximum bending stress and shear stress, and what will be the shear stress at midspan of the beam. So here the maximum bending moment definitely will occur at the midspan of the beam. So that is equal to M max, that is equal to 20 into 2 minus 10 into 2 squared by 2. So that means it is equal to 40 minus 20. So that is 20 kilonewton meter. So the maximum bending moment will occur at midspan and its magnitude is 20 kilonewton meter. Similarly, the maximum shear force will occur at the support section. At midspan, the shear stress is 0 because the shear force value is 0. Because of symmetrical loading, the maximum bending moment will occur at midspan. So therefore, the shear force at midspan is 0. But the maximum shear force will occur at the support end, that is A and B. So and its value is 20 kilonewton. At midspan it is 0. Again at the support end B it is minus 20 kilonewton. So at the support end, the maximum shear force either at A or B, 20 kilonewton. Now, you know that the area of the circular beam is pi into d squared by 4. So pi into 300 squared by 4, or you can put pi r square. So this is equal to pi into 150 square. The maximum bending stress will occur at the top and bottom fiber from the neutral axis. So hence at the neutral axis at the centroid. So from the center, the top and bottom fiber, top fiber and the bottom fiber of a circular section is at a distance of 300 by 2, that is 150 meter from the centroid or from the neutral axis. So therefore, using the pure bending equation, M by I is equal to sigma by Y, I want the corresponding sigma max, that is the bending stress at midspan, that is equal to M by I into Y max. Here the maximum minimum value M is equal to 20 kilonewton meter, already we have calculated. So that is 20 into 10 power 6 Newton millimeter M. So that is equal to M max is equal to 20 into 10 power 6 divided by I. What is I? Pi r square I am putting. Pi into 150 square by 2. Sorry, pi r square, pi into 150 square into the Y max. Here Y max is 150 mm. So the maximum bending moment Mmax is equal to 20 into 10 power 6 divided by pi into 150 square into the numerator 150. So you are getting that, if you are calculating it, you will get the maximum bending stress. So whenever the simply supported beam is having a bending moment and the loading, what will happen? The maximum bending stress will occur at the top and bottom fiber. At the top, you are getting a tensile stress of bending stress value. At the bottom, you are getting bending stress of compressive nature. Now coming to this maximum shear stress. So here circular section means Q max or tau max is equal to 4 by 3 into Q average. So that is equal to 4 by 3 into Q average is nothing but the maximum shear force divided by area of the circular section, pi r square. So that is equal to 4 by 3 into 20 into 10 power 3 kilonewton to Newton divided by pi into 150 square. So if you are calculating using the calculator, you will get the corresponding value of the shear stress. So here, you know that maximum bending stress will occur at the top and bottom fiber of the circular section. At the center it will be 0. But in the case of the shear stress, so will have the maximum value at the neutral axis, and it will be 0 at the top and bottom fiber. Here and here it will be 0 at the center of the circular section, getting the maximum shear stress. Already I calculated the magnitude of the shear stress. So you can able to draw the shear stress diagram also. So at the top and bottom it will be 0, here it is 0. You are getting a parabolic curve of, right, tau max or Q max is equal to 4 by 3 into 20 into 10 power 3 divided by pi into 150 square. So this is about the maximum bending stress and shear stress for a given simply supported beam with the circular solid section. So similarly, you can find hollow circular section also, that we can see in the next video lecture. Thank you very much for patient listening, and thank you. God bless.